puzzle for you guys. Okay, there are already sponsors giving out there are some contests going on. I happen to meet a person who's doing a PhD in trying to make a perfect sphere using pentagons. You've seen a football with pentagons? I have met a person who's doing a PhD trying to get a perfect sphere using pentagons. Let's listen to Shaunak's talk. And after this talk, I'll give you all more hints about why do you think he's trying to get a PhD in this and how did his thesis ever get approved? Making a sphere, a perfect sphere, using only pentagons. So, are we ready to settle? Prathamesh, do we have people? This is the first time in a conference we have never mentioned to keep your phones on silent. And nobody's phone has actually rung. So thank you so much. You're already becoming a great audience. All right. So Shaunak hails from Pune. He works at Amura, one of our nice sponsors. And Shaunak, take it away.
Cool. Awesome. Can you guys hear me? Yeah. Cool. So, yeah. So after an interesting keynote by Mats and hardware-y kind of talk by Shashank, let's move into the software part of things. So get relaxed, be comfortable in your seats, because we are going to see all things lazy. So what is lazy programming? What is the first thing that comes to your mind when you hear lazy programming? Well, let me tell you what it's not. It does not mean that you let an IDE do all your work. I'm sorry, Android devs, but sometimes Android Studio does more work than you. It does not mean that you ask Siri to do database migrations. Man, how cool would that be? Siri, migrate DB. Amazing. And it's definitely not about writing code on a gloomy Monday. Man, who loves Mondays? Mondays should be Sundays. So what is it then? What is lazy programming? Well, it can be a simple expression or a design pattern, perhaps even a language semantic. But wait, why am I telling you this? Because we just saw this. The first virtue of a programmer, laziness. It is the quality that makes you go great effort to reduce your overall energy expenditure, said none other than Larry Wall, the inventor of Perl. And of course, you have to be lazy to be a Ruby programmer, said by Mats. So let's be lazy then. So in this talk, we are going to cover three things: evaluation, loading, and inheritance, all done lazily. Lazy evaluation. What does lazy evaluation mean? It means we are delaying the evaluation of an expression until it's required. And let me tell you guys, Haskell is hands down the champion of lazy evaluation. There's no other language that beats it. But we are going to see how you do it in Ruby. So what lazy evaluation does is it gives us an ability to abstract our control flow. And come on, abstraction is the future. If you're dealing in primitives, you should be doing machine code right now. But we are Ruby programmers, so we do abstractions. So example, let's take a simple example, the simplest of all. All we need to do is we need to initialize an object. And before doing it, we need to check whether that object is nil or not. Seriously, guys, how hard can that be? So foo is equal to nil. If foo is equal to nil, then initialize foo as bar. Now, bar can just be a symbol or a complex, expensive operation. It can be anything. So how do you do it lazily? Use the or equal to operator. Simple. So what this operator does is basically, it evaluates the right-hand side of your expression only if it's required. So what is the requirement here? Whether foo is nil or initialized. If it is, you evaluate. If it's not, you go ahead. Well, that was simple enough, right? Let's take a more useful example. So, so you are communicating with an API and you want to fetch an authentication token. And once you fetch it, you have to use it for later communication. So how do you do it? Simple. Send a request, save the token, and pass it. That's it. You're done. But then a question arises. How could you do it lazily? What's the thing here? So check this out. We have done some changes in the code. We have replaced 2 lines in auth token by just 1 single line. So I have something. So if you can see, is the laser visible? No, forget it. So what does this line do is basically it's a 2-step process, right? We want to hit an API to get a response from the URL, and then we want to parse the token and assign it to auth token. And when we are doing it lazily, we can combine these 2 steps and short circuit the whole code. So what will happen is if the auth token is uninitialized or nil, only then the request will go to the API. And if the API call is successful, only then will it parse the token. If any of these steps fail, or if any of these steps are successful, you will just go ahead. So what we have done essentially is we have short-circuited the code to evaluate it lazily. Simple. Now this looks suspiciously like caching, right? This is something similar to caching. Well, guess what? Caching is laziness. Mind is equal to blown. Whoa. What did just I hear? Come on. Let's move on. Let's take another example. A simple one. So now what lazy evaluation does is it allows us to compute potentially infinite sequences. So let's take an example where we can apply this. So it's pretty simple. All you have to do is take first 1,000 numbers, take a sum of first 1,000 even numbers. Simple. You iterate 2,000 times, check if the number is even, and add to a sum. Come on, that's the simplest way to do it. Loop it, sum it, return it. Simple. But this looks like C programming, does it? It's kinda simplistic. That's not the Ruby way, is it? So what do? Range it, select it, reduce it. We have taken a range, a beautiful data structure in Ruby. We have run a selection operation over it, which checks whether the number is even, and we have used the reduce method to sum it all, and then we get the answer. Simple. But you've just heard about something called ranges, and you know that in Ruby you can run infinite ranges by doing one dot float infinity. So the range goes to infinity, right? So we change the code a little bit. We avoid that unnecessary multiplication. So what do? We take an infinite range, we select even numbers, we take 1,000 numbers, so the limit is 1,000, and we reduce it. But will this code work? What do you think? Will it work? No, infinite loop. Why? Because what happens is the select operator that we are looking here, it is eager loaded. So it requires the range to be an array. And since this is an infinite range, Ruby will try to create an infinite array, which will go into an infinite loop. So what can we do to avoid it? What can we do to lazily evaluate it? Simple. Add a .lazy method. That's it. You're done. This method will now calculate sum of 1,000 even numbers. Simple. But this was pedagogical, is it? It's really not helpful. So let's get real. By that, I mean real world. So we have a stepwise person lookup. So I borrowed this code from a friend. His use case was basically he wanted to have a stepwise lookup of data from a third-party API. So we want to fetch the data based on his email using a third-party service like Clearbit or Full Contact or something that you have built. And so each lookup here is very expensive. Expensive in terms of computational power or expensive in terms of money. And money matters. So what's the simplest way to achieve this? Well, we get all the lookups in one single array, and we run a loop over it, and we check if the person matches. And if it matches, if the result is success, we break and we go on. But this will eager load all our expensive lookups. So basically, all our lookups are eagerly calculated, and this method becomes very expensive. So, we don't want that, do we? We want to do it lazily. So how do we do that? So we build an enumerator. Now remember this enumerator class. It's very helpful when you're computing iterations and stuff in your Ruby programs. So we build an enumerator which basically calculates your lookups only when it's required. In this case, the enumerator is just 4 elements long, but it can be infinite. And remember one thing, calling enumerator.yield will halt the execution sequence until the next call to a .next method is made. Okay? I'll tell you what .next does in the next slide. So let's see how we can change this find match method to lazily evaluate. Simple. We have done a while loop. We have the stage enumerator set up. We are sending the email address, and we are calling .next. When we call .next, it will call enumerator.yield, which will do an expensive lookup which based on the step. So for the first .next, it will look up only phones. For the next, it will only look up phones and locations. For next, it will look up for properties. And then finally, if all of those fail, it will look for all info. So when you do stage.next, you have just one iteration done. And then you call your match service, give it the data, and check if the result was success or not. If it was, good, you're done. Break it. If it's not, go to the next iteration. And you have to remember that you have to call a stop iteration exception here, because your enumerator ends the sequence by throwing an exception. Simple. So this code is pretty self-explanatory. And for further reading, I'd recommend that there's an amazing Ruby tapas by Tom Stewart. You can read the immutable collections in Ruby, that Ruby tapa, and you can know more about this, how enumerator works and what are its details. Okay. Next section, lazy loading. So we saw what lazy evaluation was, right? It was deferring evaluation of an expression. Lazy loading is similar. It is a design pattern in which evaluation or loading of objects is deferred until it's required. Okay? And Ruby has procs which are built to store code and run it when required, right? And Ruby has modules built to write code and inject it when it's required. So can we combine these two? Yes, we can. And when we do, we can build programs that support lazy loading. Simple. So we'll be looking at an excellent library written by Ruby on Rails, which implements the same. But first, a little background info. Why did Rails require this library? Or why was it written? So as you all know, Rails is a huge project. 250,000 lines of code, 60,000 commits, 3,200 contributors. Man, do you have any more repos bigger than that? Maybe few, but not many. So with this, it has a complex loading and initializing mechanism. Naturally, such a big code has to boot up, and the booting process is very complex. So, and just like with great power comes great responsibility, with high complexity comes high boot up time. So in 2010, to improve this boot up time, Rails changed their initializing mechanism to support lazy loading. And let's see when it was done. So this is the reference to the actual commit that was placed. It was in March 2010 by Wycats himself. He introduced a new library to basically reduce the boot up time. If you want, you can check this commit out and read out the details. So that's how active support lazy load hooks was born. Now this is a library that I'm going to talk about for the next section. It is a pretty nifty library written by Wycats himself. And if you look at it, it's pretty simple. But and you feel that, man, I could have written it myself. But it has like amazing implications that you can use in your coding. So the task of this library is basically to accept blocks of code and store them in a data structure, let's say a hash, and have a calling mechanism for these stored blocks, and then call those blocks only when they are required. Simple. So accept a block, store them in hash. In this case, @loaded hooks is the hash, and the block and its options are stored. Simple. Then call the hooks when they are required. Iterate over the hash and call the blocks. And how do you call it? You have a calling mechanism which does nothing. It just does block.call or instance eval. Simple, right? Take a block, store it in a hash, call it when it's required. Basic. But how does Rails use it? If you go to activerecord.rb, at the last line, you will see something like active support on load, active record, and they have initialized an ARL table and written some more code in it. And if you go to active record base, you will see the last line is active support run load hooks. Now these two methods we saw earlier, right? On load, run load hooks. Accept blocks, store them in a hash. Call them. Accept blocks, store them in a hash which has key active record. Call them when required. Simple. So what this basically does is, when active record base is completely loaded, it calls this run load hooks, then checks all the blocks that have been stored in this name, and then calls them. So when active record base is loaded, it will basically tell the ARL engine that this active record engine is to be set up. Simple. So by calling run load hooks, Rails can call code that depends on active record lazily. And this helps Rails load code when it's required, and which in turn significantly reduces the boot up time. Example. What is the cornerstone of a nutritious Rails app? Hamburgers. I'm sorry, user authentication. Remember current user? Everybody has done device, clearance, current user, everyone knows. Yeah? You use this current user for authorization, for querying, scoping, everything. But the context here is always controllers and views. You can use that current user methods only in controllers and views, nowhere else. But what if I told you, you must use it in a model? How do you do it? Well, passing the object to every model method doesn't make sense, right? If you are implementing one method, it's okay, you could pass the current user object. But what if you are implementing 50, 60 methods? Doesn't make sense. So what do you want to do here is we want to use the current user across the app. Okay? So all you need to do is you need to store the current user in a thread local variable. Simple. Thread.current is equal to current user. But if you're using a threaded app server like Thin or Puma, it's wise to use a request store gem. It handles the clearance of all the thread local variables like niftily. So you could basically use like request store.store equal to current user. But the point here is it's not how you store it, it's how you use it. Storing is easy. Using it, that's a different task. So let's say everybody, when they start training on Rails, they build a blog application. Well, we have a similar blog applications. Now what you want to do here is you want to show the current user's comment on a particular blog. Simple. You have all the comments and you have to show my comments. Now the traditional approach would be send a user ID in the query and run it. But no, we are building an elegant app. So simple. We have the class, we have a field content declared. If you guys know Mongo, this would be pretty easy to read for you guys. Basically, what we have done is we have a title and a content. Then the blog belongs to a user. It has many comments. Simple. And it has an accessor called current viewer. So the way we write that accessor is we use an after initialized block wherein we set the current user that we have stored in the request store on the blog object. Simple. And when the my comments block method is called, we use that accessor current user. Simple. Our job is done. No need to pass arguments, nothing. Request store does it for us. Simple. So it's pretty easy. But how did we do it? Like, where do we store this current user and how do we use it here? So what we basically do is we write an initializer called current user which hooks into the Rails rail type so that it's loaded before your app is loaded, and we write a hook. Remember onload method? We use it here. In this case, we are using the action controller's power. So what we do is before every action, we check if the current user is present. If it's not, set it. Now remember, every controller inherits from action controller. So every controller runs this hook. So your device controller, your app controller, your application controller, or any other controller you have set will run this hook. Simple. You get run load hooks as inheritance. Done. Once you store it, you can use it in your model and then go about. Another example. So we have a blog application, the same blog applications, but now we want to modularize the code a bit. Yeah, we make some few changes. You can notice that the comment section is not visible here. My comments is gone, then the association itself is gone, it's missing. But we have added another line. We have said call run load hooks with the key blog. Simple. And we have separated the comments feature as a module. Simple. The module is commentable. When it's included, it adds a relationship and it adds my comments and 10 other methods that you can use later. Pretty simple, right? How do we hook it to the blog model? Simple. Add active support on load. Include the commentable module and you are done. You have lazily added a module to the blog model. Simple. So let's say our blog application is gathering some traction and we are now supporting feeds and photos and you want to support comments on them as well. So what do? We add a feed model and we add a photo model. Simple. And we add those run load hooks at the bottom so that we can inject code. And these should support comment as well, right? Your photos and feed should also support comments. Voila, it's done. Right, run an iteration, call the same methods, and you're done. Simple. So what we have seen here is basically a good design pattern in which you can use active support lazy load hooks for injecting codes. And it can be a really powerful library if used with something like Rails engines, which have a mountable approach. I guess 2 minutes. Okay. So there are plenty of other lazy paradigms like lazy inheritance, lazy initialization, and stuff. And there are plenty other lazy programming languages like Haskell. But enough laziness for today. I guess we're done. So the conclusion, well, the pipe operator or the or equal to operator is a handy short circuit operator and can be used like in many use cases. Enumerator lazy offers infinite and immutable sequences, which can be really powerful. And active support lazy load hooks is a powerful library for composing behaviors, like combining Rails engines, combining your modules, stuff like that. That's it. Oh shit, I forgot something. Thank you. There we go. We had a lazy presentation. We added a slide only when it was required. That's it. I'm Shaunak Pagnis, by the way. I work at Amura. This is my Twitter handle. The guy on the right, most of you may know. You will see him later tomorrow.
Thanks, Shaunak.
Yeah.
Round of applause, please.
Any questions?